Now, let's talk about minimizing work. The best way to minimize the work is to stay on track and course correct, like I mentioned. Airlines run this this way all the time. They put on autopilot. Autopilot is constantly making minute adjustments, but without autopilot, as soon as you take off from the airport, you're off course, and they have to correct, and then the wind blows, and then they're off course, and they have to look at the compass and redirect. So it's normal for airline pilots. A mistake teams make is, and this is huge, accepting work into the development queue, into the software team that varies in size or varies in the amount of work. Using estimation techniques, that also hasn't really panned out for our industry. We've got planning poker, we've got estimating by Fibonacci numbers. Those haven't actually worked in practice. Now, there are teams that use planning poker and use Fibonacci numbers and have reported success. But where those teams have found success is by eliminating the upper 2/3 of the boundaries and basically not accepting anything that's estimated at more than just the small single-digit numbers. Okay, and effectively they're doing the same thing. They're only accepting work into the queue that are small. Okay, which kind of fits the main point of this, but we can only estimate things that we have clear line of sight to. What has worked is using Kanban's work in process limit and standardizing the work size. And by the way, this works in factories as well. This works in assembly line work also, where the size and type of the work is standardized to be very similar. What also has worked is not pushing work into the development team that is more than 1 man day of effort. Think about it. Ahead of your coding stage, changes and new features need to be broken up into units of development work no bigger than a day of effort. Now, don't immediately think an objection. Oh, well, some things just can't get done in a day. Okay, that is true. However, when planning, the ideal that we recommend is to break up the units of work so that when your team looks at every item, they believe that each of those items can be done in a day. Now, could something surprise you and it drift over into a second day? Yes, but that's a very different situation than when the team looks at items, they're thinking, all right, that one's going to take 4 days, or that one's going to take 7 days, or that one's going to take 2 weeks. And then you work on it for 2 weeks, and then that kind of you learn something new, and that 2 weeks drifts into 4 weeks. That's very different from looking at something and say, I can get that done in a day, and then it drifts into 2, because you have more iterations, you have more cycle times to course correct and learn about it. And when I say 1 day, think of this example. You have a new feature that's a new screen in your application. And let's just take a Blazor WebAssembly application. All right, here's a feature. Well, let's design it. How are we going to do it? We have known design patterns. Of course, if you don't have known design patterns, you do a little bit of time boxed architectural work and figure out a proof of concept. But you've built screens before. Okay, we're going to need the Blazor component. Boom, that's one item. We're going to need maybe a new database table. That's another one. Oh, we're going to need a web service to get data back and forth. Okay, that's another one. We're going to need some type of command or query object to do the logic of this. That's another one. So immediately you've broken down 3, 4, 5 things. And each of them is probably well understood. And each of them, you look at it and say, oh, we've done those things before. We built a screen before. We've done data access with SQL Server and Entity Framework before. Or we've done a web service before. And each of those items are like, yeah, none of those should take more than a day to get done. In fact, I would posit that you do it that way. Some of those you're like, oh yeah, that one's going to be done before lunch. But by just by breaking it down and enumerating all of the independent items, well, now you've got things that are able to be developed in less than a day. And if you don't have line of sight for being able to clearly see what needs to be developed, you're not ready to put hands on the keyboard. Recognize that this thing is still being designed. If you have unanswered questions for how you would go about programming it, well, then we still have unanswered design questions, and we're not ready for coding. We're not ready to dispatch it to someone who's going to write the code for it, implement it. All right. All right. So splitting up the work, it absolutely ensures that we understand it and that we've decided on those design elements. Now, once coding begins on something, we do not want to have to stop because of a gap in understanding. We need to keep up the pace, or else our team moves really slowly. Like I mentioned about, you have to keep walking through the jungle in order to keep up the pace. If we're constantly stopping because our shoes aren't tied and their shoes are falling off, or our backpack is all the things are falling out of the backpack, whatever the reason we have to stop, our pace is going to really, really suffer. So we need to keep up the pace. Starting coding on something that's not ready and then having to stop and have a meeting or stop and have a conversation, just it means that we didn't finish the design on this item. Okay. So we don't want the stop, start. And something's going to run long, by the way. Yeah, it's better to have those 1-day items run into 2 days, allowing us that opportunity to stop the bleeding rather than it happen on larger items. Because if we have a 1-day item, then maybe halfway through the day we did learn something new and realize, oh shoot, yeah, we said that we were going to integrate with this third-party system, assuming that it was just like the other one, but this integration is very different. We need to rethink this. Okay, that's better to know it a few hours in than 1 week in. Okay. All right. Now, we also want to minimize work through simple and well-known designs and design patterns. And we also want to do things that, Capers-Jones publishes in his research about high quality and high speed software, like reusing defect-free components. That's in the top 5 in building quality software anyway, but it also makes delivering software faster, is reusing components that you don't have to develop from scratch. That's a whole lot of code that you don't have to design, build, test, and debug. If you can use open source and commercial components and libraries and tools and other systems that you can integrate with, then that's going to really make your team go faster, minimize the amount of work they actually have to do to accomplish the business objectives. And finally, as a part of this category, refactoring is our friend, keeping the code base easy to understand. The point of refactoring is to make a change and then have the resulting code be as if this new feature were planned to be that way all along. That's the point of refactoring. And it's not like a parking garage where we say, oh, if I want to add another layer onto the parking garage, I need to redo this foundation because it wasn't, spec to carry all that load. In software, all of our materials are virtual and we're not constrained to physics like we are when building a parking garage. And so we can, there's refactoring patterns where we can add more structural support without losing the rest of the parking garage or having to bulldoze it and start over. So that's good. Refactoring is our friend.